Hello viewers, this lecture is about circuit and packet switching for A2. So let's first discuss what is switching. Switching is the most valuable asset of computer networking. Every time in computer network you access the internet or another computer network outside your immediate location, or your message are sent through a maze of transmission media and connection devices. The mechanism for exchange of information between different computer networks and network segments is called switching. So let's start with circuit switching. Circuit switching is a method of implementing a telecommunications network in which two network nodes establish a dedicated communication channel or circuit through the network before the nodes may communicate. The circuit guarantees the full bandwidth of the channel and remains connected for the duration of the communications session. Uh, Circuit switching uses a dedicated channel or circuit which lasts throughout the connection. The communication line is effectively tied up. When sending data across a network, there are three stages. Number one, first, a circuit or channel between sender and receiver must be established. Number two, data transfer then takes place, which can be analog or digital. Transmission is usually bidirectional. After the data transfer is completed, the connection is terminated. Now, let's discuss packet switching before we go into their comparison. So, in packet switching, uh, packet switching is a method of grouping data that is transmitted over a digital network into packets. As you might have an idea, a network packet is a formatted unit of data carried by a packet switched network. A packet consists of control information and user data, which is also known as payload. The user data inside a network packet is called a payload. So packet switching is a method of grouping data that is transmitted over a digital network into packets. Packets are made up of a header and the payload. Now, what is a header? Header refers to supplemental data placed at the beginning of a block of data being stored or transmitted. So all the data about the data which is being transmitted inside a packet is header. So packets are made up of header and payload. As I told you that payload is the user's data. Data in the header are used by networking hardware to direct the packet to its destination, where the payload is extracted and used by the application's software. Packet switching is a primary basis for data communications in computer networks worldwide nowadays, and for internet as well. Packet switching is a method of transmission in which a message is broken up into number of packets that can be sent independently to each other from start point to end point, which you can see in this image. The data packets will need to be reassembled into their correct order at the destination. So, as an example of packet switching, the steps are each packet follows its own path. Routing selection depends on the number of datagram packets waiting to be processed at each node. And all these nodes that you are watching at are actually the routers. The shortest path available is selected. Packets can reach the destination in a different order to that in which they are sent. Now, as you can understand that the packet switching, let's discuss about packet switching in comparison with circuit switching. Uh, the old telephone system that we call PSTN, plain uh, old telephone system, public switched telephone network, as in, uses circuit switching to transmit voice data, whereas voice over IP VoIP uses packet switching. The replacement of traditional landlines by internet-based communications, as from your landline to the cell phone, communication protocol is mainly due to the benefits of packet switching versus circuit switching. However, there are still advantages to using the uh, circuit switching. We compare packet switching and circuit switching, let's say. So circuit switching is used for traditional landline phones, whereas packet switching is used for voice over IP and in cell phones. Circuit switching transmits data over a predetermined path, whereas packet switching transmits data the fastest way possible. Uh, Communication paths are exclusive to two parties in circuit switching, whereas in packet switching, multiple users share the same communication line. So packet switching and circuit switching are different methods of routing data from one destination to another. The journey of the data takes is called the path. The journey the data takes is called path, and the devices that make up the path are routers, switches. They all are called nodes. The major difference between the two approaches is that circuit switching relies on physical telephone lines to transmit the data, while packet switching uses the internet. So let's discuss the circuit switching pros and cons. So uh, in short, advantages of circuit switching is that they are more reliable connections, better audio quality, generally more secure, and the disadvantages are networks are more expensive to use, build, and maintain for circuit switching, and inefficient use of networks bandwidth. Now let's discuss in greater detail. So advantages and pros of circuit switching are: the circuit used is dedicated to a single transmission only. The whole of the bandwidth is available. The data transfer rate is faster than the packet switching. The packets of the data or frames arrive at the destination in the same order as they were sent. A packet of data cannot get lost since all packets follow in sequence along the same single route. Uh, Circuit switching works better than packet switching in real-time applications. And the disadvantages of circuit switching are: it is not very flexible. For example, it will send empty frames and it has to use single or dedicated line all the times. Nobody else can use the circuit or channel which when it is idle. So a circuit between two devices is also called a channel. The circuit is always there whether or not it is being used. So it is being wasted if nobody is using it. If there is a failure or fault on the dedicated line, there is no alternative routing. So if we have got one circuit and it is broken, so no way to communicate. Dedicated channels require a greater bandwidth. Prior to actual transmission, the time required to establish a link can be long. Now, in circuit switching, the path is dedicated and it is decided on before the data is transmitted. The system decides which route to follow based on a resource optimizing algorithm, and the transmission goes according to the path. For the whole length of communication session, the path is exclusive to both sides, and it's released only when the session terminates. When you make a PSTN call, public switch telephone network call, you rent the line actually. Therefore, if somebody else calls you, they get you, they find you engaged. Therefore, if you speak for 10 minutes, you pay for 10 minutes of the dedicated line. That's why international calls are expensive. The benefit is that circuit switching is more reliable than packet switching, so you don't have to worry about the drop calls. Now, packet switching pros and cons. So advantages of packet switching are more efficient use of the network bandwidth. Networks are cheaper to build and maintain. Automatic rerouting helps prevent drop packets. Whereas disadvantages are poor connections and call quality, more vulnerable to outside data interference and security threats, unpredictable latency. Latency is the time it system takes before the actual data starts transferring. Now, let's discuss pros and cons in greater detail of packet switching. So the advantages of packet switchings are no need to tie up a communication line. It is possible to overcome failed or faulty lines by simply rerouting the packets. It is easy to expand the traffic usage. Circuit switching charges the user on the distance and duration of a connection, but packet switching charges users only for the duration of the connectivity. High data transmission is possible with packet switching. Packet switching always uses digital networks, which means detailed data is transmitted directly to the destination, as in the case of cell phones and computers. Whereas disadvantages of packet switching are the protocol for packet switching can be more complex than those for circuit switching. If a packet is lost, the sender must resend the packet, which wastes time. It does not work well with real-time data streams. Um, the packet switching circuit or channel has to share its bandwidth with other packets as well. There is a delay in the destination at the destination while packets are reassembled. Uh, Packet switching needs large amount of RAM to handle the large amount of data. So these were few of the um, advantages and disadvantages of packet switching. Uh, the Internet Protocol IP breaks data into chunks or packets or segments and wraps the packets into a structured way, uh, which actually we call packets. Each packet contains information about the IP addresses of the source and the destination nodes, along with the data load, which payload, which is the actual user's data, sequence number, and other control information. A packet can also be called segment or datagram, as we discussed already. In packet switching, the packets are sent toward the destination irrespective of each other. Each packet has to find its route to the destination. There is no predetermined path. The decision as to which node to hop to in the next step is only taken when a node is reached. Each packet finds its way using the information it carries, such as the source and destination IP addresses. Once the packet reaches the destination, the packets are reassembled to make up the original data again. So, which one is better? With voice over IP, you can use, let's talk in terms of voice over IP only and landline. With the voice over IP, you can use network node even if other people are using it at the same time. There is no circuit dedication, the cost is shared. The downside is that when you use a circuit that is open for other services, then there is a possibility of congestion and hence delays or packets loss. This explains the relatively lower quality of voice over IP calls compared to uh, public switch telephone networks or PSTN. Fortunately, the other protocols have been developed, such as TCP/IP, to make sure that voice over IP connections um, work properly and they remain reliable. Now, so circuit switching is kind of always better than packet switching, but its maintenance is tougher. So comparison of circuit switching and packet switching. In circuit switching, actual route needs to be set up. A dedicated transmission path is required. Each packet uses the same route. Packets arrive at destination in the correct order, and so on and so forth. Now, sometimes what actually happens is that it is possible for packets to get lost and keep bouncing around from router to router and never actually get to their destination. This is something common. Eventually, the network could grind to a halt as the number of lost packets mounts up and clogs up the system. To overcome this, a method called hopping is used. A hop number is added to the header of the packet. Each packet is only allowed to hop a finite number of times. This number is determined by the network protocol and routing table which is being used. Routing table is the table used by the routers to send packets on the routes. Each time a packet passes through a router, the hop number is decreased by 1. If the packet has not reached its destination and the hop number is equal to 0, then it will be deleted when it reaches the next router. So then TCP/IP network makes it possible that the source sends the data again. Then comes error checking. This is quite possible that when packets reach to their destination, they would have lost some of the payload. So for that, an error checking routine sort of checksum is used. Each packet also contains an error checking technique, such as checksum or parity check. If checksum is used, this value is calculated for the packet and it is added to the header before it is being sent. The checksum for each packet is recalculated at the destination to ensure no errors have occurred during the transfer of the data. If the checksum values are different, then a request is made to resend the packet. A priority value is sometimes also added to the header. A priority value indicates which packet queue should be used. So this is it. It is not a much complex topic. All you have to remember is how the two switching techniques differ from each other and which one is better and which one is not for certain type of communications. And most hopefully either we will be discussing this in exams in terms of data transfer with files or data transfers in the form of voice. So that's about it. Thank you very much.